Before we discuss the net filtration pressures, I wanted to discuss the regulation of GFR in our afferent and efferent arterioles. If you remember, we have two types of artery regulation. We have myogenic and tuboglomerular feedback. Within the myogenic regulation, you should remember that it's stretch activated. In our vasculature, as it expands, as blood pressure increases, the intrinsic properties cause it to contract as calcium is released. So myogenic is stretch activated. That's about all you need to know for that one. For the tuboglomerular feedback, you should know what happens with GFR, and when it's increased, when GFR is increased, the macula densa cells sense increased sodium passing by. So if we have increased GFR and increased sodium, then we release adenosine, which causes afferent arterial constriction. And when we constrict the afferent arterioles, we stop the blood from going into the glomerulus, and we decrease our GFR, and thus we have a negative feedback system. Does the opposite if we have a decreased GFR. If the macula densa cells sense a decrease in sodium passing by, then our system releases nitric oxide. And when we release nitric oxide, it causes afferent dilation. And if you remember, afferent dilation increases the amount of blood passing into the glomerulus, which effectively increases blood pressure, and again, we have our negative feedback system.